Hello everybody, I am Dr. Emre Süren. Now we continue our AI agents for offensive security course. Here in this lecture, we will study accessing website. We performed reconnaissance. We identified the port numbers that the web service is running. Now it is time to interact with the web application. But before starting, I have some news. You know Kali. We are using Kali in our experiments. Here in the latest post, which has been released 10th of March, they tell about Ollama, Fire, and large language models. Let's click read more. Before starting, I just want to mention which client we have been using during our course. Exactly, we are using also Fire. Here Kali also prefers using Fire with Ollama. We also use Ollama through Fire, right? This is our Ollama and this is our models. Super nice QN. So let's see what they describe in their blog post. First, they are using Ollama on Kali, but we prefer using Ollama on our host operating system, in my case macOS. This is the installation of Ollama. Now they install by using this command, then installing the large language models like Llama and QN. So now they show which models they have installed. They prefer also running QN3, which is also one of our models, and they are using MCP server Kali. So let's look at the details of this project. As you see, this is our MCP Kali server that we have been using during our experiments. I guess I have one improvements on this project, Hydra, but still it is not accepted. It has been around 2 weeks. But anyway, you can find my fork. Here, my fork, you can just fetch it. During our exercises, we are using this fetch. And Kali is also, unfortunately, not updated because it uses the original repository. And this is the tests and how Fire can connect. As you see, Fire here, providers. From providers defines Ollama, IP address, localhost, and it can access the 3 models. And we explained how to use tools during this communication. Here it sends an hello world message and gets response. In our cases, we started directly with security tools. Here the configuration of Kali server and this is the tools that you can access. And it accesses nmap scan module to show us how it works. And exactly this is what we have done during our course. Let's close it. It's good to see from Kali offsec. Now we are coming back to our client. Let's see what we have done in our latest exercise. We provided the IP address and we wanted our models to identify the port number. Now I will create one new chat. I will paste my prompt here. So as you know, once I created this chat under AI agents course, it automatically inherits system prompt here. And this is the default model. I'm not sure what happened. Well, let's click new chat. Probably we found a bug. Let me close it. Close this. Fire, quit. Open again. Cool. Now it connects to our tools, Kali Web. These are the tools that we can access. As you will see in the newer version of this MCP client, you will see additional parameters here which clarifies how Hydra can be used. Otherwise, pretty much all models are falling into traps. And this is our reconnaissance guideline. This is the target, JVT vulnerable, and this is the web page. Let's refresh if we can access. Now we have seen the request here. Cool. Here, yes, we can see the interactions with the MCP server. So now let's continue with our test. Now we will add something on this prompt. Target is this IP address, discover the open ports, prefer faster scan first, then interact with the service that has highest potential to have a vulnerability that will leak the CTF flag. And I will use Gemini. Then we will try our Ollama and the models that we are running locally. It directly found our nmap scan and got the response 5000. Meanwhile, we can look at it started brute force, but it is getting 404 error message. Here, let's see nmap. Now it is using Nikto to find vulnerabilities. So it took one another way. Normally, what we are expecting, it first interacts with the web page, find the home page, and understands there's a login and try to bypass this login. Instead, it tries to find some hidden files or just using Nikto scanner to identify some sort of vulnerabilities. But it also told us it is going to use Nikto. Based on behaviors from our model, then we will tweak, we will fine-tune our prompt. Okay, now it received an error, probably it is a timeout error. Nikto is still running, but requests has been stopped, and all the time it's getting 404. Yes. Let's look at here. As you know from our previous lab exercise, unfortunately models hangs up once they run into failure while we use Fire client. Okay, it wants to use GoBuster now. Probably we will see a large chunks of HTTP requests from GoBuster. This is due to my mouse actions. Nikto got an error and it made GoBuster scan request, but we cannot see on our MCP client. As you see, our MCP server is not. Now we have seen the second Nikto request. We need to see GoBuster request also. We need to make this MCP client server more stable. Once I have time, I will study on this also. Okay, GoBuster started. I'm sorry, I'm unable to proceed with the scans. I will try to access the web page via browser to see what it is. Okay, now what we are gonna do. Interact with the web page by using curl and then try to understand the web page, and based on your understanding perform more logical security test. I don't want to use attack or something intrusive. And map scan. Normally, now I can provide directly the service number to bypass and map scan stage to make things faster, but I am trying every time to see how much our model is consistent across tries. Probably our desktop client Fire having issues with the Kali MCP server because it's a very basic Python code. So it thinks that it is not able to get responses. This is GoBuster. I want to stop this generation. Now I will ask, the target is, and you found 5,000 visibly toward running a web service. Interact with the servers by using curl. Let's go. it still tries GoBuster, but I want our model to select brute force. So now we see that how much our models needs our supervision. This is another bug from Fire. I'm going to stop it. Still GoBuster continues here. I want it to stop also, because it interferes with our executions, subsequent executions. I want to show everything to you because you will get familiar with Fire. Once you run into these issues, you're not gonna get amazed and you will know the truth about the capabilities. We are expecting this tool also stop in 3 minutes because it is the threshold. I stop the service, I rerun it, then I will send my prompt again. Stop generation. Wait in the chats. Okay, we are having issues with our MCP server, that's why I'm going to shut down and restart. Maybe it's also good to restart from here also. Stop, start. Interestingly, it asks GoBuster, then switch to Nikto. Nikto started. GoBuster first started, then Nikto, but it decided to also use curl, but it's a bit of late. This is the curl command. It got error, GoBuster error, Nikto error, GoBuster. All right. This is our application. All right. I don't want to ask my model to perform brute force because I want my LLM to reason about login page. It's a login page. We need to perform brute force attack. For it, we have Hydra tool. So I will configure Hydra to run it. This is what I am expecting. Meanwhile, I'm customizing our prompt. before using any type of scanner, first interact with the web page to understand it. Okay, let's start again. We instructed our model to refrain directly using Nikto or GoBuster, but still we didn't explicitly wrote the name of the tools because we want to be generic as much as possible. It says I tried Hydra, but getting errors. It started to use Hydra, but it's using the word list from the TMP username directory, but we don't have such a word list. Okay, now I will provide some word lists. You know, we have some word lists under Kali, under USR share word lists. Let's metasploit try user. Okay, I will suggest using this list because it is relatively shorter. Stop generation. I will put it here. But still, I'm not going to tell it use this list to perform brute force. This is the one of the things that I have seen YouTube videos. People are feeding their LLM models with the write-ups. This is not right because we are just providing the solution of the target. It will not improve the capability of the large language model. We should only provide general information. This is known as a one-shot learning. Otherwise, it's not a one-shot learning. Past, not txt. Okay, I will also stop here. Start again. Then maybe stopping here. Run. And let me copy this. Tools. Stop. Start. And here again. Let's make it more readable. If you decide to perform brute force attack, you may use following lists as user name and password that are common word lists in Kali. Again. It started Hydra, curl, try to get access flag, again Hydra, 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 and started sqlmap. Stop generation, and we will understand what is happening with Hydra, what is wrong. The Hydra command seems to be having issues with syntax. Okay, let's see Hydra here. I'm gonna copy it, copy selection, paste here. So let's see Hydra, 4 threads. This is the username -l-p password list, and this is the IP address. This is the HTTP post form, login. Okay, actually this is wrong. This shouldn't work like that. Let's try it. I don't believe it's gonna work, so it's gonna give error. So usually the port number should stay in the as a last parameter. 5000, and we don't put anything after HTTP post, and directly you write the username, user, password, pass, submit, login. If the answer is successful, it should appear login message. Optional parameter must start with /. Okay. Let me see how we use Hydra. Target IP address, login. Okay. Like this. Invalid. This is another usage. User, password. Okay, let's try like that. Invalid. Okay. Username admin, password is 123456. Yes, it works. Now we understand that this is the correct format, then that's why I will directly feed copy selection. Our model is not able to find the correct format, that's why I will use my format. Copy. The correct usage of Hydra is below. Let's write target IP because we don't want to write directly the solution. Yes, we have received this command here. Still we didn't receive the response. Yes. It successfully found because it made a request with curl with post request to the form field, login form field, and it grabbed the cookie. It tries to upload PHP reverse shell, but we don't know why it reasoned about this. So for this lecture, I would say we successfully found the username password pair and we successfully bypassed the login page with this payload. For this lecture, I would say it is enough. Then we will continue to finding additional vulnerabilities or directly the flag on the platform, on the target. Thank you. I am Dr. Emre Süren.